In this podcast, we will cover inverse variation and joint variation. In inverse variation, as one value increases, the other value decreases. Think of reading a book. The more pages you've read, the fewer pages you have left to read. Or if the area of an object remains constant, as for example on a rectangle, as the length increases, the width decreases. The general form of inverse variation is y equals k over x to the n, or in proportional form you can say x to the n times y equals k. This is very similar to what you did in Algebra 1 where you said y equals k over x. The difference between a direct variation and an inverse variation is that instead of using multiplication, we use division. As an example, we have y varies inversely as x and y equals 14 when x equals 3. Our goal is to find x when y equals 13. In the first method, just as in the first method we used for direct variation, we solve this by finding k first. So we start with our basic equation, y equals k divided by x. Y equals k being y varies, and then the inversely means divided by, and x followed. So we have 14 equals k over 3. So in this case, k is going to equal 42. So now if we put that into our general equation, we get y equals 42 over x. Now it's asking us to find x when y is 30. So here we have 30 replacing y equals 42 over x. We're still solving for x. So multiply both sides by x, 30x equals 42. Divide both sides by 30, and we get x equals 1.4. The other method is to set it up in the proportional form, and this is again very similar to what we had with direct variation. If you take the basic where you know both values, y sub 1 equals k over x sub 1, and multiply to solve for k, you get x sub 1, y sub 1 equals k. On the other side, if you have y sub 2 equals k over x sub 2, you get x sub 2 times y sub 2 equals k. Since they both equal k, it means they equal each other. So x1, y1 equals x2, y2. Now solving the exact same problem using this method, we knew that when x was 3, y was 14, so 3 times 14 equaled x, which we didn't know, times 30. Notice this time we're just not finding the value of k first. So we get 42 equals 30x, and we still get x equals 1.4. In joint variation, you have a value that varies directly with two or more values. So you have more than one variable on the other side. One of the three variables will be constant. The other two can change. For example, you could make the length constant and the width and the height could change. If you make the width constant, then the length and the height would change. The general formula for joint variation is y equals kxz, or kx to the n, z to the n. In the example we have below, we have a physics problem where work done varies jointly as the charge q and the voltage V. And they asked us to find the equation of joint variation in a capacitor with a charge of 0.004 coulombs and a voltage of 100 volts when it performs 0.2 joules of work. We start with setting up the equation. Now notice it said work varies. That's why I started with W equals K. And then since it was jointly, I knew I had a multiplication problem, and I just needed to know the remaining variables. So the two remaining variables were Q and V. So my equation was W equals KQV. Now I simply took the numbers from the problem. Work was 0.2. K, I did not know. The charge, or Q, was 0.004. And the voltage, or V, was 100 volts. I simply substituted in the values, solved the equation, and came up with 1/2. So in this case, W equals 1/2 QV, and we have solved our equation. This concludes our podcast on joint variation.